We need to find the open circuit voltage here V0 and the power dissipated by each of the resistors 4.7 kilo ohms and 3.3 kilo ohms. So in order to find V0, I will apply voltage divider rule. So V0 is the voltage, 160 is the total voltage, V0 is the required voltage that we want to find out, and 160 is the total voltage divided by sum of the two resistances 4.7 plus 3.3, and since we want to find the voltage across the 3.3 kilo ohms, we just multiply by 3.3. So that's the voltage divider rule. So that's 66 volts. Now we need to find out the power dissipated by each of the resistances. So if we talk about the first the resistance 3.3, so P 3.3 kilo ohms, the power dissipated by this one will be V square by over R. So V square is 66 square. Now when we write R, we have to write in terms of ohms because the given value is in kilo ohms. So 3.3 times 10 to the power 3 because we are converting into ohms. So that's 1.32 watt. That's the dissipated power here. And for the 4.7 kilo ohms resistance, that will be first we need to find out what is the voltage across that. So what I will do, instead of again applying voltage divider rule, I will just subtract 160 minus 66 volts because the total voltage here is 160 and this one is 66. So what is this one? That will be just the subtraction, which is so 94 volts here, the voltage drop across this one. So 94 square V square, so 94 square over 4.7 times 10 to the power 3 because I have converted it into ohms. That's 1.88 watt. So these two we know now. So the third part of the problem is, let's say we have resistors available that have a rating of only 0.5 watt. So we have to find appropriate resistances R1 and R2 so that the voltage drop here V0 is unchanged. So we will have to replace the values of the resistances because we want to have the same voltage drop here, and of course in effect same voltage drop here as well. But the power rating of the resistance is 0.5 watt, but we are seeing that in these cases, in the previous one, the power dissipated by both the resistances is higher. So what we will need different value of resistance, and of course we will need a higher value of resistance. So let's do this one, P 3.3 V square over R. Again this will be R2. So 3.3, now we know this is 5, so this one is now given. This has to be 0.5, that's the maximum value, so our resistance will be this much or more. So anyway, this one will be 66 square still, and R2 is unknown, so basically R2 will be 0.5 over 60 and then 66 square over 0.5. So basically R2 has to be either this one or more so that the resistance does not burn out basically. So that gives me a value of 8712 ohms, which can be written as 8.712 kilo ohms. And of course when we will just look up, we have to find a resistance which is just above this one, the closest value, maybe 8.735, whatever is available. So that's there, and then R1 will be similarly 90 V square over power, which is again 0.5. So basically the same formula here, I have just written it directly now. So 0.5, the power is in the denominator, so 94 square over 0.5, that is the R1. So this is 17672 ohms or 17.67 kilo ohms. So these are the values of resistances, required values.